Hello everyone. This time we are going to learn Relational Database and SQL. Actually SQL is pronounced as SQL. Okay, SQL means that SQL. Okay, this is Unit 3 for Class 12 Computer Science subject. Now understand what is a relational database. Okay, actually or why we are going to learn this topic. Actually what happened in large organization where so many data is to be processed or we have to work on large amount of data, then there is a need that a different type of systems which can store these large amount of data, and whenever we need some information, some particular information, quickly we can get that information from that large amount of data. Okay, first we are going to learn databases. What is a database, how we can collect or store these large amount of data in an organized way, and then further we are going to learn SQL or the SQL. It means through this it is a query language. Through this language we can write one line or two line commands, and then we can get particular information from that large amount of data or from that database, from that table. Okay. Now we are going to learn in detail one by one what are those things. First we are going to learn that is database. Here the definition is: a database is defined as an organized collection of data or information about an entity, something that exists or things. It is a shared collection of related data or information used to support the activities and decision making of a particular organization. It serves as a container which may contain various database objects. A database therefore is considered as a repository of stored data. Means a database, what is this? It is an organized collection of data. Okay, so many data in an organization. There are so many types of data. Employees information is there. Okay, some clients information is there, some customer information, products information. Okay, how many products we have ordered, how many products we have in the store. Okay, these type of information is to be processed. So to keep these data in an organized way, in a better way, in that way that we can we can get the information and in a particular way. Okay, now also it helps us to share the data, the collection of data information between different departments. Okay, and further we can take some decision making. Information can be obtained from that databases. These features can be available with the help of databases. That's why we store data in a computer by making database. Okay, so it is considered as a repository of stored data. Okay, now a database has so many parts. Okay, we have to learn one by one what are those parts. First we are going to learn that what are those parts. See, first one is known as database. Database, it is the complete collection of all the data. Now next is now in a database, data are not just stored there in a haphazard mode. First we have to create a table or file there. Then in each table there are records of information. We have to keep records of information. Okay, rows of information, row wise information we have to keep, and then each row may have different types of item, different types of data. Then those are organized in a particular field, and then so many types of data are there. Some data are of date type, some data are of character type, some are numbers. Okay, so data or characters, how we have to organize all these things. Okay, see, we one by one we are going to understand these things. First we are going to learn field. Okay, field. What is field? A field is a set of characters which are used together to represent specific data in elements. Suppose in a table, okay, in a table we can keep information, tabular information. Say for example some product information we can store, and each product have some number, okay, product number, then a name is there, then its price cost is there, and then some discount may be there, or how many stocks are available in the organization. Okay, this type of information we want to store. Then this information can be stored in a table. Okay, in a table, then each column in a table can be said as field. Okay, an individual data item within a record is known as field. Suppose a particular product information, say for, or say you can take example of a student name or student details. Here we have taken the example. See here, what is field here? See, some information we have taken here: roll number 20, then a name Sonia, and the age is 14, and marks we see have got 90. Then this whole information is known as a record. Okay, a record. Then this record contains 4 different types of data. Then each different type of data is stored under some particular name. Okay, 20, the number is stored under the name roll number. Sonia is stored under the name, and then 14, a number is stored under the name age, and then marks contains 90. Okay, these names are known as field. These names are known as field. It can also be said that the individual item, individual data of a record is known as field. Okay, this is the field. Now next one is roll number, and the example of field is roll number, name, like this. Record. See, a collection of fields is termed as record. When we collect so many information from different fields, then it is known as record. You have taken the example, seen the example in case of this Sonia's name. For example, a student record consists of the roll number, name, age, or marks. Next, file. What is a file? A collection of logically related records is called a file. So suppose we have got so many records of information of different students, then this particular whole information of different students, records of information, can be logically stored in a file. Okay, a file is also termed as table. In database management system, a file is termed as table, or also it can be called as relation. A table has rows and columns, where rows represents records or tuples, and columns represents the attributes and fields. Okay, rows represent tuples or records, it can say. Columns represents attributes or fields. For example, the entire information about all the student can be stored in a file, and that file is called as table or relation. Now next one is database. Database is therefore a place where related information is stored and various operations can be performed on it. It is the highest unit of the organization, file organization. Okay, it is the highest unit, that the more it contains large amount of data. A database contains so many tables, so many fields, so many records of information may be there. Okay, so many data of information may be there, and this is the larger collection of all the information, that is known as database. Okay, now come to next. What is database management system? In short, we have to say DBMS. We can see here what is a database management system. See here. Okay, say database management system. It gives us features to administer the data, control the data. Administer the data means which data we have to keep, which data we have to delete, how we can keep these data. These things are these facilities are available with the database management system. Database technology and management. Okay, which type of technology is to be used, what is the language, what is the command system maybe there through which we can filter data from that particular database system. Data planning and modeling methodology, which type of model this database management system is using. Okay, we will learn these types of data model, different types of data model we will learn. Okay, users, how many users a database management system can handle. These things is to be kept in mind before choosing a particular type of database management system. Now understand here, database management system are specially designed applications that connect the user and the program. Okay, user and the program, and store data in an organization. Okay, these three things, user, program and data, stored data. Okay, a database management system is responsible to connect all these things with each other. Okay, the purpose of DBMS software is to allow user to create, modify and control a database. DBMS system, in short we can say that DBMS system allows us to create a database. Okay, or we can also modify these databases as per the requirements, and also we can control this database. Okay, which table we have to keep, which record we have to keep, which data may be updated. These things is to be controlled using the database management system software. Further, see, a DBMS is an electronic or computerized record keeping system. Okay, we can also say that it is a computerized record keeping system. It maintains the various pieces of information in an integrated and summarized form instead of keeping them in separate independent files. Okay, while we are using different types of files in a computer, but here in database management system, all the information is stored at one place. Okay, these are not stored as separate files. Okay, so many examples of DBMS software is that MS Access, it comes with Microsoft Office, Word, Excel, PowerPoint. Then MS Access is there, Microsoft Access. MySQL is there, PostgreSQL, SQLite, Microsoft SQL Server, Oracle, SAP, DBase, FoxPro. So many softwares are available. Any software we can use. But however, we have to study in this course, computer science course, this MySQL. We have to learn MySQL. Now, DBMS gives us so many tools for different type of activities, different type of works. First, it allows us to store data in a structured way. Structured way means organized way, in the way that a record can be stored. Some fields may be there, table, rows and columns are there. Okay, in that rows and columns information is to be stored. That is known as structured way. Query the database, ask questions about the data. Sort and manipulate the data in the database. Validate the data entered and check for inconsistencies. Validate means data, what is to be entered. Okay, before storing some data in the database, it validates that is it correct, it is valid or not. Say for example, if we store a date like 30th February, then this is invalid data. 30th February never comes. So before storing a date, it checks that it is a valid data or not, then only it stores. If it is validated, if it is correct data, then only it stores in the database. Okay, these are checks while entering into the data. Then you can think, you can understand that how a database management system keeps information and checks the inconsistency, and then we can we can say that these data are reliable. Whatever the data is stored in the database are reliable, and we can trust those data. Okay, produce flexible reports. Reports can be produced both on screen and on paper that make it easy to comprehend and information stored in the database. Also, it maintains data consistency in case of multiple users. So many users can use a same database and update those databases so that each and every user get the real data, okay, at the real time. Need for the database. Why we need database? Everywhere database is used. Everywhere. Okay. Suppose some software. How this is the end user. Okay. End user means the user which uses the database. It sends while using the computer. This end user sends a request to the database management system that this type of information we need, this particular information we need. It gives the request to the DBMS system, and DBMS system fetch the data in the database and then retrieve that data and then reply to that end user that this particular information we have found from that database. You check it. Okay, this is the working of this particular database management system. And then what is the basic need of the database management system? Organization needs that so many increased competency is increased. Okay, so competition is increased between different organizations, different products, different type of work. Okay, so many competitions have increased. Okay, then this DBMS helps them to keep up with the other organizations in the competition. It saves time. Okay, it has security features. Okay. So security features, unauthorized person cannot access those data. Flow of information are stored in a flow, and within seconds we can get a particular information in the database. That is the particular need of database system in an organization. See, understand here. A database system is used to eliminate the problems of data redundancy. What is the meaning of this data redundancy? Actually, in traditional file system where physical file is needed to store some information, registers are there. Okay, large registers or khata bahi, like these things are there. Okay, then that time what happened, if another department has to keep some information. Okay, so 3 or 4 departments are there in an organization, and all 3 and 4 departments deals with different types of data for particular for a single person or for a particular employees or particular customer. Then what happened there, data are duplicated, so many information are stored so many times. Okay, keep same so many times. And then what happened, some updation is done. Suppose some phone number is changed or address is changed, then which record is to be trusted? It becomes cumbersome, it becomes unreliable data, and that is known as data redundancy. Data redundancy it means that duplication of data problems. So database system, what happens, it eliminates the problem of data redundancy and also data inconsistency. Okay, invalid data, if we before storing the data, where data are validated that it is correct or not, then mostly inconsistency is removed at the time of data entry. So what happened, database system gives data redundancy and also data inconsistency. Mean data is, whatever the data is stored in the database, we can trust on that data. Okay, so inconsistency is totally eliminated. It does not maintain separate files for different applications. Rather, it works on centrally maintained database, which means that the data is kept at one place and all the applications that require the data may refer to this database. It helps that whenever any file gets updated, okay, The updated version of the file is available to all the application using database system. At the same time, whenever the updation is done, then all the application which uses the same database get updated at the same time and get the updated information at the time. So data redundancy and data inconsistency are controlled to a large extent. That's why we need database management system. Now again, components of database system. So many components are there in a database system. Okay, see here. A database system may have end users, those uses those databases. Then database application software is there, database management system software is there, and then finally the database which is kept in the computer's memory, in hard disk or somewhere else. Okay, so these are the components of a database system. There are 4 components of a database system. First is user, second one is database application, third one is database management system, and fourth one is database. And then what is a user? If you want to understand better, then see here, users can be varied types, usually database administrator, system or application developers, and end users. These are the users of the database system. Now what is database application? Data application may be personal, departmental, enterprise or internal. It may be general purpose or customized as per the need of the user. Depending on the user, different types of database application softwares are there. Okay, managers need different type of application software, different types of database application software, and then clients uses different types of application softwares. So for each and every type of users, there is a separate database application software, and overall all the database application softwares uses the same database. Next is database management system software. Software that allows user to define, create, access and manage database terms as a database. For example, MySQL and Oracle. These are the softwares which needs when we want to create a database, when we want to create a table, when we want to store data in a table. Okay, for that purpose DBMS software is needed. And then last one is the fourth one, that is database. And we have known that what is a database? It is a collection of data, logical data, okay, related data. Now so many advantages are there of database management system. One by one we are going to learn what are those advantages of DBMS. First one is elimination of data redundancy. Data redundancy means duplication of data is totally up to larger extent. This data redundancy is eliminated. A database management system eliminates data redundancy, duplication of data, by integrating the files so that multiple copies of the same data are not stored. Next one is data consistency. A DBMS provides data consistency to a larger extent, as the changes made at one place are reflected at all other places or all the users. Sharing of data. By using a DBMS, not only can existing applications share data in the database, but new application can also be developed to operate against the same stored data. Okay, so many we have seen that there are different database application software for different types of users. So sharing is there because each and every users are using the same database. Okay, same data in a same database, then sharing is there. Okay, sharing of data. Then reduced programming effort. A DBMS saves a lot of programming effort, since a user need not write programs for query processing, that it provides easy retrieval of data. Okay, reduced programming effort means there is just application software gives buttons or that menus options, just we have to click on that button and data we will get the required data. Next, it enforces standards. Standards means with centralized control of database, the DBA, database administrator, can ensure that all application standards are followed in the representation of data. Actually, what happened, some stored data, suppose names, in particular names is to be stored, okay, and so many users are there. Some users may store a particular name in capital letters, all capital letters. Some may store first letter of each word in capital letter, and then rest one in small letters. Some may store all small letters. Then this does not keep the data in a standard format, and this database ensures it can be instructed like that, it can be programmed like that, it can be set like that, all the data is stored in a particular standard format. Okay. Improved data integrity. Data integrity refers to the validity and consistency of data stored. If data is stored, data consistency, data is stored, no duplication is there, automatically data integrity is achieved, so that we can trust those data. Then privacy and security is there. Data security refers to protection of data against accidental or intentional disclosure to unauthorized person. Okay, so many security levels are there. Password system is there, PIN system is there. Okay, so data is secure here, and unauthorized person cannot access those data. Economical is there, combining all the organization operations data into one database and creating a set of applications that work on this single source of data can result in cost saving. Cost saving, it is there. Cost saving is there because if once we have developed this type of system, then we have to concentrate only on reporting or getting that particular data. Okay, one time investment is there, and then further it is economical. And then next, ninth number, advantages like improved backup and recovery system. Okay, a database system provides facility for recovery from hardware or software failures. Okay, software may be failure, hard disk can be corrupted, okay, files can be corrupted. So there is a system we can keep backup, and then further if system is damaged, then this backup can be used to restore the data. These systems are there in database. And then meeting enterprise requirements. Since many types of users with varying levels of technical knowledge use a database should provide a variety of user interfaces. Okay, meeting enterprise requirements. Enterprise requirements means whenever we need different type of systems, it is database management system is capable for those things at the same time. Okay, these are the advantages we have learned. There are totally 10 advantages we have learned here. Okay, in addition to these, so many other advantages are also there in DBMS. Database management system models. Before we learn about this database management system models, we must know that before the data is computerized or stored using computers in a computer memory. Okay, so many models, so many prototypes, so many systems have been developed to store data. How we can large amount of data, how we can store this some large amount of data in a computer, and not only storing the data, also it can facilitate us to get a particular information from large amount of data at once, at a fraction of seconds, at a few seconds it takes, and we can get a particular information. Okay, so different types of models, prototypes have been developed. Some prototypes worked, some prototypes doesn't work. So we are learning here that those prototypes worked, but some prototypes worked well, and some prototypes worked but not up to the expectation of the users. So we are going to learn different types of database management system models, and then finally we will learn the model which works in all aspects of the requirements of the users. Okay, see here. What is data model? Data models define how the logical structure of a database is modeled. A data model is an integrated collection of conceptual tools that can be used to describe the structure of the database. Structure of database means how we have to store the data in a computer using computer memory, and how we can retrieve those data as per our requirement or as and when we require those data. So many conceptual tools have been developed. Okay, this is known as database model. Database model define how data is connected and how it is processed and stored inside the system. They organize data for various users, how various users can get those data. Now, a data model should be able to give best data representation and should process the following desirable characteristics. Okay, to be a data model, okay, with and able to give best data representation, these are the desirable characteristics, that those data models should have these characteristics to qualify that they can give best data representation. What is this? Data models should be presented graphically using diagrams and symbols. Okay, diagrams and symbols can be made to represent data model. Next one is data representation in a data model should have no data redundancy. Okay, data redundancy, duplication of data should not be allowed. Okay, in any case. Next, a data model should be made available and shared by various applications. It is capable to share with various applications, various users, various platforms. Okay, these are the conditions, or these are the characteristics of a best data representation model. Now, data represented should be consistent, stable and valid in all aspects. Whatever the data is stored, okay, in a database, those data must be consistent, means valid data, stable data and valid in all aspects. Okay, these are the characters to be a data model which can give best data representation. Types of data models, according to so many models have been developed, and these models have been categorized under these types of models. Data models are categorized into three different categories. What are those categories? First one is object-based data model, then record-based data model, then physical data model. Under record-based data model, which we have to learn, okay, record-based data model, there are again three different types. First is known as hierarchical model, next one is network model, and then relational model. Now, one by one we are learning these three different types of models. Okay, which are record-based models. Hierarchical data model. Hierarchical model represents a hierarchy of parent and child data segments. Okay, in hierarchical there is a relationship is represented like that. There is a parent and there is a child. It is represented by an upside down tree. A tree is developed, but this tree is upside down. Okay, hierarchical model depicts one-to-many relationships, one between a parent and a child segment, like this. IBM's IMS Information Management System and System 2000 are examples of hierarchical data management system. Okay, IBM's IMS and System 2000, example of hierarchical database management system. Now here see example of hierarchical data model. In hierarchical, how a data is stored and how they are linked with each other. Suppose a student information is stored here, and this is known as parent. Now roll number, we have to keep roll number, then name and address. And then suppose this information is needed in library, then this library is using this information, student information, and then again it is keeping like that data like this. Roll number taken from the parent student table, and then ticket number and book issued information is kept inside it. Now suppose this exam department using information of that particular student like this, roll number, it is taken from that parent. Okay, then first term marks, half yearly marks and annual marks are stored like this. Then in fees department, information is stored like this, roll number is taken, and then tuition fee, development fee and total fees information is stored like this. These are linked like this in a hierarchical data model. Okay, see, so many advantages are there in hierarchical model. It is simple in operation and concept, very simple. Okay, it promotes data sharing. Data can be shared using hierarchical data model. Parent-child relationship promotes data integrity. Data integrity is there, okay, because we are using the same roll number for each and every department. Then data is integrated, means correct data is there. And then it is efficient and can be naturally mapped for one-to-many relationship. Okay, one-to-many relationship can be matched. So what is one-to-many relationship? See here, student information, one student information is stored here, and in fees department, okay, different months fees or different categories of fees can be stored in separate rows or separate records. Okay, for one child there may be 12 months and some other or more categories are there. Then this model is known as one-to-many model. That's why some limitations are also there. See, what are those limitations? It is inflexible for non-hierarchical relationship mapping. Suppose we want to represent this data in non-hierarchical model, then it is inflexible. We cannot decode those data in non-hierarchical mode. Next limitation is implementation is complex and difficult since it is done using pointers. Every time there is a pointer, means we have to keep roll number from parent record. Okay, and this roll number is to be kept everywhere, and this works as a pointer. This is unnecessary and it is difficult and complex. That's why dependency on parent node, which is the root node, and its deletion can cause deletion of all child nodes and in turn entire model. Dependency is there in the parent record. Okay, so if parent record get deleted, then rest of the information have no value. Okay, or those information have no value, so entire model is destroyed. Next one is changes in the structure requires changes in all application. If somewhere needs to be changed, then we have to change the entire application. This is the major limitation is there in hierarchical model. So the next model we have to learn, that is network data model. What is this network data model? Just see here, a network model is a database model conceived as flexible way of representing object. What are the limitations in hierarchical model? Those limitations are tried to be removed here. Okay, so it becomes flexible way of representing objects and their relationship. It consists of collection of records connected to one another through links, thus allowing multiple connections among the nodes. The network model provides the capability to handle many-to-many relationships. Further advancements updation is done here in network model. It supports many-to-many relationship. In hierarchical model, one-to-many relationships can be established only, but here many-to-many relationships can be established. Examples are like this: UNIVAC DMS 1100 and DBMS 1020, from DEC are examples of network database management system. And this is the example of network data model. See here, okay, parent and child information is taken like this from hierarchical. Okay, same information is stored here, and then same library information is taken here, then exam information is taken, fees information is taken here, and some links have been developed so that each and any information can be connected with each other. Okay, like this. These are the network model. Now, advantages of network model. What is the advantage? It can handle more relationships types. Many to many relationship, multi-parent relationships can be established here. Then data access is easy and more flexible. We can easily access any data. It includes DDL, data definition language, as well as data manipulation language. And what are those things? We are going to learn these things. Okay, so don't worry here. It promotes better data integrity. Data integrity is more controlled here. Some limitations is also there. What are those limitations? See, the system is quite complicated in its structure since there are several numbers of links. Okay, this is the major disadvantage of network model. What is there is so many links is to be established. Okay, so it limits efficiency. Structural changes require changes to be made in all application programs. Some structural is to be changed, so in application 2 we have to change. A high-level language interface is required to interact with the database. Okay, we have to use language, computer language, to interact with the database, to get the information, to filter the information from the database, which is added limitation in the network model. Extra memory is consumed for holding pointers or links. The links, everywhere we have to create links. Those links need extra memory, so memory consideration is not done here. So we are going to learn relational data model, and this is the topic we have to learn in detail in this chapter. In a relational data model, data is organized in two-dimensional tables called relations. Okay, in tables we have to keep the information. In tables we have to keep the information. Two-dimensional means there is row and column. The tables or relations are related to each other. A relational database is based on the relational model developed by E.F. Code. Who have promoted this relational data model? E.F. Code. In this type of database, the data and relations between them are organized into tables having logically related records and containing the same fields. Okay, how it is organized, or it is stored in a information here. It is having tables, and tables having records, and records having fields. The contents of a table or relation can be permanently saved for future use. Thus, this model is simple and has all properties and capabilities required to process data with storage efficiency. So this is the relational data model which is being used almost every database management system software nowadays. So many characteristics of the relational database is there. Data is conceptually represented as an orderly arrangement of data in rows and columns. Okay, or number wise, roll number wise, or some system of ordering system is there. In an organized way we can store data here. Each relation is represented as a table. Columns described in a table are the attributes that belong to an entity which is modeled as a table. Every row in a table represents a single entity. Okay, all the values in a relation are scalar. That is, at any given row or column position there is one and only one value. Okay, all operations are performed on the entire relation and result is an entire relation. These are the characteristics. Now some advantages are also there. A relational model provides a structural independence by using independent tables. Okay, information. Okay, one type of information is stored in one table. another type of information is stored in another table. So independent structural information of data is there. Changes made in the table structure do not affect the data access or other application. If table structure is changed, then there is no effect on other part of the program. It is represented in the form of tables, so it is simple and easier to understand. Anyone can understand what is a table. Tabular view also provides easier database design, use, implementation and management. Okay, each and every information is to be shown in tabular view, which is easy to understand also and easy to represent also. Okay, generate also. Built-in query support based on SQL is provided by RDBMS. Okay, each and every RDBMS software, Relational Database Management System software, is having integrating the facility to query their database using SQL language. Okay, so SQL language is also easier to learn, and this language is a standard language, and easily we can use these things. Our data organization and manipulation is easy, flexible and faster. Then powerful structure designing and processing capabilities of RDBMS isolate the end user from physical level details and thus improve implementation and management simplicity. Actually, how the data is stored in computer, that is not relevant for the end user. Okay, end user, that how the data are stored, and about those details they need not to be known to the end user. The end user has to deal with only the data in tabular format. Okay, this makes the easier for the end user also and the developer also. Now we are going to learn this relational database in detail. First we are going to learn definition. Relational databases are based on the relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in a table is a record. Each row is a record with a unique ID called the key. Now, what happened in a table? Okay, to keep individual record, individual row as a unique row, then each and every row is provided with a number or a unique number or unique ID, and this unique ID is known as key. Okay, the columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish the relationship among data points. Often data is a relational database is organized into tables. Every time a relational database organizes data using tables. Some terms related to relational database is given here. These are basic terms which we should know before going deep into the relational database management system. See, those terms are entity, attribute, tuple, cardinality, degree, domain, and body of the relation. Entity. What is this entity? An entity is something that exists and about which we can store some information. For example, student entity, employee entity, item entity. Okay, an entity is something that exists and about which we can store some information. Say for example, a student entity is related to a student, so many information we can store. Okay, say for example, roll number, name, address, contact number, fees details. Okay, exam marks details. This information can be stored. Those are known as entity. Next one is attribute. The term attribute is also used to represent a column in a table. A table consists of several records, rows. Each records can be broken into several smaller entities known as fields or attributes or columns. Okay, a field of a table a column of a table is known as attribute. For example, roll number, name, address, gender, these are the example of attributes of a student entity. Next one is tuple. Each row in a table is known as tuple. It is also known as row or record. For example, the student table has 10 records. Then if a table has 10 records or 10 rows, then we can say that this table is containing 10 tuples. Next, cardinality of relation. It is a number of records, total number of records or tuples in a relation, in a table. Total number of rows in a table, or we can say total number of tuples in a relation, is known as cardinality of that particular relation. Thus, the cardinality of a student relation is 10. Okay, so if 10 tuples are there, then we can say that a student relation is having 10 cardinality. The cardinality of the relation is 10. Degree of relation. Degree means the number of columns or attributes is known as degree of relation. The total number of columns in a table or a relation, total number of attributes in a relation is known as degree. Thus, the degree of relation, student relation, is 4. If 4 column is there, then we can say that the degree of that particular table is 4. Domain of a relation. It is a set of all possible values that an attribute may contain. For example, in a table, a student domain for field gender is 2, since it can have either M or F as the possible values, available values it can contain. Actually, domain, what is domain? In a particular attribute, particular field, the total number of values, the total values, the unique values we can store, we can keep in that particular column is known as domain. Say for example, if a column is having a name gender, and then in gender we can only save 2 values, male or female. These 2 values are the domain of that particular attribute, gender attribute. Okay. Now, body of the relation, it consists of an unordered set of 0 or more tuples. Okay, the tuples, the collection of tuples or collection of rows or the records is known as body of the relation. Okay, see example here. These are the attributes. This is a relation. A table is a relation. Okay, and each and every row of a relation is known as tuple, and each and every column of a table or a relation is known as attribute. See, 1 2 3 4 5 tuples are there, and here 5 tuples or 5 rows or 5 records are there. And in attributes, 1 2 3 4 attributes is there, 4 fields is there, 4 column is there in a relation. Okay, see example here also. These are the attributes. This is a table. Okay, and here total 10 records are there, 10 records. Then these 10 records are known as tuples. Total 10 tuples is there, and the number 10 is the cardinality of this table, cardinality of this table. And then degree, the total column or the attributes, total number of attributes of the relation is known as degree. So 4 1 2 3 4 total attribute is there, then degree is considered here 4. Now in gender field, we can keep only 2 values, male or F, male or female. Then this is the domain of this gender attribute. Okay, then address column is there, name column is there. These are the different attributes are there. Understood? Now this is a key, primary key. Okay, this we are going to learn in the next topic. Database keys. What is the key? Actually, what happened in a table, in a relation, each and every information is to be given a particular unique number, unique ID in a separate attribute or separate column. then this unique number or set of unique number or set of unique IDs which uniquely define each and every row is known as a key. Okay, so keys are very important part of relational database. They allow us to identify an attribute or a set of attributes on the basis of which a table is identified. Actually, it is an identification number for each and every record of a particular relation. They are used to establish and identify relation among two or more tables. Okay, if two or more tables is joined, or from two or more tables we are getting some information, then these keys are very much helpful at that time, making relationship between these different tables. They also ensure that each record within a table can be uniquely identified by a combination of one or more fields within a table. Okay, now so many different types of keys are there. Okay, now there are primary keys, there are candidate keys, there are alternate key, foreign keys there. Okay, understand here, a primary key in one line, if you want to define in one line, one sentence, then you can define like this: a primary key is an attribute or a group of attributes that can uniquely identify tuples within a relation. Candidate key, a candidate key is one that is capable of becoming the primary key, that is candidate for primary key position. An alternate key, a candidate key that is not the primary key, is called an alternate key. And a foreign key, a non-key attribute whose values are derived from the primary key of some other table, is known as foreign key in its current table. Okay, just these are the definition of different types of keys. Now we are going one by one in detail that what are those things. Okay, first we are going to learn primary key. A primary key is a set of one or more attributes or fields which uniquely identifies a tuple or rows in a table. Sometimes what happen, to uniquely identify a particular row or record, we need more than one columns. Okay, or sometimes only one column or one number is sufficient to uniquely identify a particular row. So this number is known as, or this the column which is having those numbers is known as primary key. Okay, the whole column is known as the primary key. So for example, roll number column in a student table is said to be that it is a primary key of that table. Now some features are there for primary key. What are those salient features? It is always unique in nature. Unique means for each and every row there is a unique identity, unique number or unique alphabet or unique code for each and every row, so that uniquely each and every row is to be uniquely identified. And it is non-redundant, no duplication keys, in no duplication number should be there. It does not have duplicate values in a relation. Okay, next one is it arranges the table in its own order. Okay, according to this primary key we can arrange the whole table. It cannot be redeclared or left null. Okay, null cannot be left. Okay, left blank. Null means blank. Blank cannot be left in a particular row. Each and every row must be given a particular number, a particular code to uniquely identify that particular row. Then this is the thing. Okay, we cannot left blank. Next one table can have only one primary key. However, primary key can be a combination of more than one field. Okay, so each and every record or each and every table or relation can contain only one primary key. However, a primary key may be a combination of one or more fields, one or more attributes. Okay, it is possible, but only one primary key is to be declared there. Now candidate key and alternate key, what are those things? Candidate key. A candidate key refers to all the attributes in a relation that are candidates or are capable of becoming a primary key. Okay. We have learned that these are the features of primary key. So accordingly, we can identify that number of attributes may pass those categories, those characteristics. Okay, so all the fields, all the attributes which can become a primary key is known as candidate key. And next one is alternate key. A candidate key that is not the primary key is called an alternate key. In other words, any attribute that is candidate key for the primary key, which is capable of becoming a primary key but is not a primary key, is an alternate key. Okay, from candidate keys, list of candidate keys. Okay, candidate keys means the keys which can become primary key or known as candidate key. Okay, from all the candidate keys, only one key is to be taken as primary key. Then rest the left one candidate keys are called alternate keys. Okay, so the formula is here. Alternate keys are those keys, okay, where there is candidate keys and then we minus the primary key. Then all the other keys which does not become the primary key is known as alternate key. We can also say that candidate keys are those alternate keys plus primary key. Alternate key plus primary key is all the candidate keys. Okay, see an example here. What are those keys? All the keys here. Okay, see candidate keys. This item ID and item name all are having some unique values. Unique values means different values in each and every row. Then this both column can become primary key. So the both column is said to be candidate keys. See here, both are candidate keys. Yeah. And from these two candidate keys, one has considered as primary key. Item ID is considered as primary key. See here. Then the rest one candidate key is called alternate key. This is item name. Now it becomes alternate key. It does not become primary key, then it is known as alternate key. In the same example, in other table example, you can see here in the supplier table, okay, two columns are there and each and every column is having different values in each and every row. So both column can become primary key. So both are candidate keys. Both are candidate keys. Now out of two candidate keys, one has considered as primary key, then other become the alternate key. Understood? This is the formula. Now the last one key is foreign key. You have to understand here. A foreign key is a non-key attribute whose value is derived from the primary key of another table. In other words, a primary key in some other table having relationship with the current or original table. Actually, what is there? This foreign key can be established, can be created, can be defined when there is a relationship, when there is a relationship established between two or more tables. Okay, then only this foreign key can be defined. Here you can see the example. And what is this foreign key? It is a non-key attribute. Non-key attribute means need not to be a unique value in each and every row. Need not to be unique value in each and every row. Those type of key is known as non-key attribute. So foreign key is defined in another table, and the values in those column is taken from the primary key of the other table. See example here. Foreign key. Here, this is the employee table. Okay, and this is the department table. In department table, this designation code is defined as primary key. This is the primary key. Okay, primary key. This is the primary key. Now in employee table, this designation code is entered, and this designation code is taken, okay, from the department table, and from the primary key of the department table. Then this column, this designation code in employee table will become the foreign key. Okay, this is the foreign key. Understood? This is the foreign key. Okay, foreign key is a column which contains values from other table primary key. Other table primary key column of other table. This is the foreign key. Now we have learned so many things today. What is database? What is database management system? What are its advantages? Different types of models we have learned, different types of keys, different types basic terms. What is tuple, degree, cardinality, attributes. We have learned so many things. Now it's time to do some exercise, and these are the exercises we are giving you here to do it yourself. Okay, and thank you. Hope you understand the topic well.